Hello, today I'm explaining to the 7th week assessments for artificial intelligence course. The first course we need to use the California housing dataset. We choose the train dataset because the other ones is have some empty places in dataset. And the first task I used the train data, not test data, and I download and here I upload this data and I print the column names. After that, we choose the median house value for the target value, the target features, and the other all features, other all value. We put the X and with using the drop function. After that, we need to do split the train and test data for more generalization of the for testing. And here we split and I choose the three different algorithms because in the task I want to do choose the three different algorithms. After that, we need to do perform grades for the all function because grades try to the different level of order of these algorithms and choose the best for the uh, best performance. Choose the best performance. We use that, and here we calculate the R square value for the compare the all this. When we run this code, firstly write it to the all values names column names, but it can be a little bit time for processing, but I have the output in my code here. Yes. When we compare this, firstly we need to understand the R square value because R square value is meaning to it can be 1 to 0, and if 0 is nothing match, but if is 1 is meaning the can explain to the data with predict. For example, here 0.82% of the 82% of the data match and suggest. Here, when we compare the random forest best performance in all these algorithms, a second one decision tree, and the last one is the linear regression. But it's all is the positive side, is the bigger than 0. But the best performance random forest. For second task here, we need to implement the other value, other features, and we need to recalculate the R square value in the one algorithms, and we need to do uh, both compare, explain to the in the code. Here we need to do firstly implement the room per person, and after that we check the correlation of the room person and the median house value. Now here we check the correlation coefficient of this both, and after we separate the targets and features like the old code, we split data sets, and we make the model and we teach the model, train the model. After that, we need to see the result. When we run this code, we can understand this the room per person and median house value here correlation in this correlation is lower. It's actually positive side, but it's so low. We can say the have more impact for this data set. But when we check to the R score, we can see this score increasing in the normal because here we have to do lower 82, but now we have the 83. We can say the room per person have a good effect for the random forest because I use the random forest algorithms here, and we can say that it's a good effect. After that, the last task here, we need to do check the polynomial orders, and we need to increase the order, and we need to see the result. It's mean the polynomial orders is the meaning the when increasing higher order equations are squared to are cubic. And when we in our code, when we check here, uh, we set the all the same. We is our first target value, and we separate this. We do the same. Only we change here the polynomial degrees 1 to 3. We change them, and we calculate the all terrain and test data set for the all value in the data set. And we write it to the r square value. Now I will run and I explain to the final result. Okay, now we see the all the degrees increasing for test and train, and I looked and I searched these results in my mind, and my final decision is when generally when the polynomial degrees are increasing, the r square value increasing too. This is the best part. Is the closer the best performance, the more performance. For example, here the medium income, the test value is increasing. The every polynomial degree is increasing. But we can't say to do for all this value, all these features, and some features when the polynomial going to high order test value lower than the train value, but we expected different. But in the some case, it's the low count case, but generally, is polynomial degrees increasing, our two score going to increasing too. It's the 3 degree is more complex, but better performance in the generally. We can say that.